Hey everyone, and welcome to my video on basic differentiation. In this video, I'm going to explain how to differentiate, the concept of differentiation, how to tackle these sorts of questions, and yeah, by the end of the video, you should be able to differentiate yourself. So just a note, I call it basic differentiation because there are more advanced concepts or rules, but in this video, I'm just going to explain, your standard differentiation question. So along the way, I will explain how to tackle, these sorts of questions, why we do what we do, and give you a bit more deeper understanding, as well as teaching you how to differentiate. So getting into the basic concept of differentiation, we have d over dx of x to the power of n is equal to n times x to the power of n minus 1. Now that might not make a lot of sense, but let me break down each part of this. So d over dx, that just means we are differentiating with respect to x. So differentiate with respect to x. If you had y is equal to x to the power of n, you would do dy over dx because you're differentiating y with respect to x. But don't worry too much about that part for now, but that means to differentiate. This is just x to the power of n, so we're differentiating x to the power of n, and it's going to be equal to n times x to the power of n minus 1. So all we've done is brought the n down to the front, and then we've taken 1 off the power. And that's it. That's how you differentiate. So let's go through an example. We've got question number 1 here. We've got 5x squared. So I'm going to do it one step at a time. So that is equal to 10x squared. So all I've done is brought the 2 to the front and timesed it by the 5. So I brought the number or the power from the top, brought it to the front, and multiplied it by that front number. So now we need to subtract 1 from the power. So it's going to be 10x squared minus 1. So it's going to be 10x to the power of 1, which is just to the power of 1, which is just 10x. So you don't need to do all that work in. I just thought I'd do that to give you some understanding for the video. So for example, with this one, you can give it a go yourself if you want. So that is equal to, we've got a 4x squared. So we bring the 2 down, so that's 8x. 2 minus 1, so to the power of 1, just going to be 8x, okay? So that's the final answer for that part. Now, this is a bit more, when you have a constant, so a constant is like a 7 or an 8, it's a constant because it doesn't change dependent on what x is. So that's why it's called a constant, because it's constant, it doesn't change. And when you have constants, you can get rid of them. So you can just do that. Why can you get rid of them? Well, you don't need to know that, but I'm going to explain why you get rid of them. So for example, let's say you have, let's say for example you have the 3 again. What is 3? Well, 3 is 3 times 1. 3 is 3 times 1? What's 1? Anything to the power of 0. So it's going to be 3 times x to the power of 0, so which is equal to 3x to the power of 0. I'm sure this is like an official concept. This is just my interpretation of it, but like I didn't invent this obviously, but like this is my understanding of why this happened. So for example, if we had 3x to the power of 0, well, if we brought the 0 down, you're timesing everything by 0, so it'd be gone. So it'd be like 3 times 0 times x to the power, and then you take a minus 1. It doesn't matter because you've times it all by 0, so it disappears. If that makes sense. So that's why you can just get rid of the constants. So that just goes. Okay, so that's one rule for constants. And when you integrate, you actually add back in a constant, but you don't know what it is, so you just do like plus c, but that'd be a different video. And integration is the opposite of differentiation. So differentiation, you're kind of like breaking down a bit, and integration, you're kind of like building up a bit. So I don't know if you want to give question number 3 a go, but I'll go for it now anyway. So we got that equal to, so we bring the 4, we got 2x to the power 4 if you can't see. So we do 8 times x to the power 3, because we brought the 4 down, subtract 1 from the power. Now another interesting trick is like if you have 7x, 5x, 100x, a million x, you can just get rid of the x, you can cross out the x. So it would just be plus 7. But why can we do that? Well, a similar concept to this, and you basically just use this. So what is, I've gone blank now. So, okay, so 7 is, what did I say? It was 7x, yeah. Okay, cool. Sorry, I got confused. So 7x, that is equal to 7x to the power 1. Well, you would do is equal to 7 times 1, so 7x minus 1, so to the power 0. Anything to the power 0 is 1, so it's equal to 7 times 1, which is equal to 7. So if that doesn't make sense what I've done there, we can get rid of the x, because 7 is this, or 7x is equal to 7 times x to the power 1. So what we've done is we brought the 1 down, so we're doing 7 times 1, and then we take 1 off the power. So 7 times 1 times x to the power 0. X to the power 0 is 1, because anything to the power 0 is 1. So it's just 7 times 1, which is 7. Hopefully that makes sense. But again, you can leave any comments or questions if any of this doesn't make sense. But yeah, that is basic differentiation. Honestly, once you do it like a few times, it'll just click and you'll be like, it'll be really straightforward. I might put some questions down below, or put some questions in afterwards, maybe some answers or something, I'm not sure. Let me think about it, and you can give it a go yourself. Maybe I'll put some at the end of the video and I'll put some answers in there too. Cool, so yeah, I hope that makes sense. Best of luck with your maths, and thanks for watching. Hey everyone, so following on from, well, I guess we're in the same video, but let's do some practice questions. And this time I've decided to put them as y equal to, now same thing, you just kind of write it like as dy over dx, and I figured like I might as well do the dy over dx, because I figured some people might be a bit upset, like they'd be like, oh, you didn't do that in the first part. But yeah, the technique is still the same. You just, if you're doing the question where it's equal to y, you can just write this, you know, annotation or whatever you want to call it. So let's get into the video. I'll show you how to do question 1, and then hopefully from, you know, the previous part of this video, you'll know how to do the others. So we've got y is equal to 2x. So you just write it as dy over dx, because you're differentiating y with respect to x. So dy over dx, okay, that's equal to, now we differentiate, and as we know before, when it's just an x, we can just cross that out. So crossing that out is equal to 2. So dy over dx is equal to 2. I don't know if you want to pause the video and give the others a go. I don't know if you would still not get the marks if you didn't write dy over dx, but like, it's good practice to do. And you know, most questions, they're going to put it in the form y is equal to yada yada. But if it isn't, if they're like, oh, can you just differentiate, you know, this equation, you could do like d over dx, or you could probably just start writing it, to be honest. But I'll let someone else answer that. But this is how you this is how you differentiate. So I will give you guys a second, and then I will start answering the questions. So answering the questions, question 2, 3, 4 we have left. Y is equal to 4x to the power of 4 plus 3. So dy over dx is equal to, remember we bring the power down, so we got 16x, take 1 off the power, 3, so we got 16x cubed, or to the power of 3, and what we do with constants, we just get rid of them. There we go, sorted. Question number 3, we've got y is equal to 2x squared plus 5x. So I thought I would just have some fun with that, but that is dy over dx, I promise. Same technique again. So 4x, and we take 1 off the power, so it's to the power of 1, but so that's to the power of 1, but you can just write it as that. Plus 5, because when it's just the x, you get rid of it. Now for this, and again, like hopefully I'm not going too fast, but the first part of the video should hopefully, you know, explain. But again, any questions, drop them down below. Dy over dx is equal to 9x squared, 3 by the 3, take 1 off the power, plus 8x, so it's just going to be 8 because we cross that, and then the 1 goes because it's a constant. So hopefully that made sense, hopefully it was clear, and yeah, it probably is best to use the right sort of annotation for good practice so people can understand you're working as well. But yeah, I guess on the first part I kind of left that part out, but I mean, yeah, if you're doing it properly, probably should do like d over dx, just so people can see it working and everything. But yeah, hopefully that makes sense. Maybe I'll do one on integration, I don't really know, but I do work full time. I've got some time off right now, but so I don't know how often I'll be uploading, but if this goes well, hopefully, yeah, I can do more. And yeah, so best of luck with all your maths, and thank you so much for watching.